Okay, to begin with, we're just going to look at writing each of these in the form x plus a all squared add b. This is just regular completing the square that you should be familiar with from normal GCSE maths. So if we're going to do this, then the first step is to begin by halving the coefficient of x. We'll have a look at why we're doing that in a second if you're not clear. So we'll call that x plus 3 all squared. So the value of a will be 3. Now the reason we've done that is because if we expand this, we get x plus 3 squared, which means multiplied by itself. And if we multiply that out, we get x squared plus 3x plus another 3x, which is 6x, which is what I wanted here. But I'd also get a 9, which is not what I wanted. So what we've got to do straight away is take away 9 to get rid of that. So take away the 9 and then put that 1 back on the end. So when we tidy that up, we get x plus 3 all squared, take away 8. And again with the bottom one, we can begin by halving the coefficient of x in the middle there to get x minus 4 all squared. But when I expand x minus 4 all squared, I'm going to get x squared minus 8x, which is what we're after from over here. But I've also got minus 4 times minus 4, which is positive 16. So to get from there, so I need to instantly take away the 16 to cancel that out, and then I've got minus 5 on the end. So again, tidy it up, and it's x minus 4 all squared, take away 21. And you might not have seen this symbol before. This infers that this is an identity, which means that we're finding values of p and q that make this statement always true for all possible values of x. Now, there's a couple of different approaches we can take to doing this. You could technically do this question in exactly the same way as before, but I'm going to begin to look at something called equating coefficients here. So I'm going to set to work on this right-hand side first, instead of just working from the left-hand side. So I'm going to expand all of this, and when we multiply out these double brackets, we get x squared minus px, which will be minus 2 lots of px, plus p squared plus q. So what we're going to do now is equate the coefficients in each of these things. We've got our x squared term, and we've got our x squared term. We've got minus 6x is minus 2p. So the 2p bit here has to be referring to this 6 here. So we've got that 2p is 6, so p must be equal to 3. So now we can use that to help us find this last part. This p squared plus q bit on the end here is going to be referring to the 2 term. It's not got an x in it, so it can't be referring to anything else. So we've got that p squared plus q must have a value of 2. Well, we can use what we've already worked out to help us here, because we know that p was 3. So we've got 3 squared plus q is 2. So 9 plus q is 2. So q must be minus 7. So the values to make this statement always true are that p is 3 and q is minus 7. Yep, another similar example that we can set about in exactly the same kind of way, just a little bit trickier. Now, we're going to begin exactly the same way by manipulating this right hand side. So that's x minus 3 all squared. We'll do that first, and then we'll multiply through by a afterwards. So we've got a lots of x squared minus 3x, which will be minus 6x, plus 9, plus c. So then we multiply through by the a, and we've got ax squared minus 6ax plus 9a plus c. And now we can begin to equate the terms. if we're looking over here, we've got ax squared. Well, a must just be referring to this number here, so a has to be equal to 2. B, this number here has to be referring to the minus 6a part. So minus 6a equals b. We already know what a is, so that's minus 6 lots of 2, so minus 12. B must be minus 12. So then we've just got to go and work out what c is. And c, if you remember, is going to be equating to the terms on the end. So 9a plus c must equal the term on the end, which is 5. So 9a plus c equals 5. And again, we already know what a is because we worked out at the start. So 9 lots of a is 18 plus c is 5. So c has to be minus 13. Another similar question here. So we're going to begin by expanding this. So x plus b times x plus b plus c. So when we do this, that will give us x squared plus bx plus bx plus b squared, which will be x squared plus 2 lots of bx plus b squared plus c. And then we'll multiply it through by a to give us ax squared plus 2ab x plus ab squared plus c. And now we can begin to equate this. So we've got the a value here must be corresponding to the 3. So a must be 3. And then the 5 here must be corresponding to all of this in front of the x here, which is 2ab. So we've got that 2ab equals 5, where a was already 3, so we've got 2 lots of 3, which is 6. So 6b is 5, so b must be 5/6. And from there, we can use that to help us work out the final term. So that's worth minus 1, and that's the number part on the end here. So we've got ab squared plus c equals minus 1. And we're just aiming to work out c here because we've already got a and b, where a is 3, so that's 3 lots of 5/6 squared plus c is minus 1. And 5/6 squared being 25 over 36. So this is 3 lots of 25 over 36 plus c equals minus 1. And I'll move over here, that's 3 lots of 25 over 36 is 75 over 36 plus c equals minus 1. Probably tidied this up a little bit actually here. 36 over 75 is going to be 2 and 3 over 36, so 2 and a 12th. So I've got 2 and a 12th plus c equals minus 1. So if I just bring that over to the other side, by taking it away from both sides, we're going to have c is minus 3 and 1/12. So that's our values of a, b and c, all worked out by equating the coefficients.